Hi all. Cool. I'm going to give a talk on context-driven AI agents. I'm sure everybody in the room already knows about generative AI and probably have heard of this term for like almost the entire year now, and maybe before that as well. Before I start, I would like to give a quick intro about myself. I'm Shubhangi. I currently work at Admiral in the UK. It's a financial services company. I've been in the space of data science and AI for the last, I would say, most of my career. These are all the forums I have spoken on or been a part of or like work basically in some capacity. And I also have a nonprofit for women in data, basically for most of the women who want to build a career in tech and like basically don't have any opportunities available. So this is me in a nutshell. So before we start, I would like to ask, how many of you have already had this experience? Any raise of hands, any smiles? Okay, I can see a few smiles. So yeah, I guess it's true for most of us. So this is where the topic of today actually fits, because everybody wants to use AI, but none of them, or actually most of them, don't get it right. And this talk probably would be a nice follow-up to the previous talk as well, because it is going to cover some of the bits which are actually needed to make AI enterprise level, which means if you're trying to go and create something which is production ready, which most companies are trying at the moment. So, for example, if you see this statement here, which I gave to one of the AI agents I have built, the answer was inexplainable. Basically, the question I asked was, what does this mean? Is it a Jira ticket, a customer ID, a pipeline, a KPI attempt? What it is? And with generative AI or ChatGPT, Claude, basically any tool that you use, it's the case. Simply because LLMs, they work on natural language processing, which means like the way we communicate with them actually matters. And to harness the technology or the tool that you use, it's extremely important to have two things, not just one, which is prompt and the context. Now, initially when generative AI came, everybody was like, hey, prompt engineering will be like the next big thing. And everybody was just like learning to how to build natural language prompts. But that's not the case. And things transformed pretty fast. And now we are in the era of context engineering, which is already there. If you had asked me 7-8 months ago, I would say it's pretty new, but now it's full out there. Like it is actually an engineering discipline. So from that, I want to talk about how LLMs have evolved. Now, this term has been everywhere. Like everywhere means every single technology that you could study is basically talking about it. So 4 main reasons why we have moved where we are, like why agentic systems or AI agents or things like automations are actually blooming or like coming across in technology. Firstly, LLMs are growing and becoming more and more sophisticated every day. And that is not like far from reality, from 3.5 to 5.1 where we are. Second is, we don't see LLMs anymore as a tool where you can like, hey, write a query and get an answer. It's not Google Chrome. It's actually looked at as a strategic partner by most businesses today, and simply because people and businesses want to save time and money. And large language models facilitate that to a very large extent if you build the right agent. And third and fourth is actually also straightforward. A lot of businesses have complex requirements. For example, if you're working in a healthcare industry or financial industry or legal, you have complex requirements. And because communicating with LLMs is easier, simply because they use prompts, you can actually create something simple and complex at the same time. And then lastly, need of a systematic method, which basically gathers a lot more information. So this is how LLMs have reached where they are over a very relatively shorter span of time. So now let's talk about 2 main things and understand the difference. So prompt, if you see, is about phrasing the instruction. It's about how you write. It's like you write a code, right? It's the way you phrase that instruction. But context is different. It's about building the system around that model. A lot of people, when they build applications, they think, oh, my model is bad, so my application failed. But most of the time it fails because the context is not right, or they haven't given enough information, which is why the LLMs fail drastically. And imagine a scenario where you have actually built and spent months and months for an agent or any particular LLM application, and at the end of the day, nobody uses it. And if your application is used by somebody who is, let's say, 60-year-old, 65 years old, or maybe a young person, they don't know what the right answer is. So in that case, context becomes a really, really important part to build something which is production ready and which actually can be used by enterprises. Now, look at this. If I say it's cold, this is, for example, I have given a prompt to an agent. This is probably like the three answers it would give. Or could be more, because this statement is pretty vague, right? Because it is not giving anything. I am stuck in an island where there's a lot of snowfall. I don't know how to get there. What do I do? I asked this like prompt to ChatGPT, and it gave me like these potential ways of like dealing with it, like 3.5. And I was like, hey, this is not what I wanted, but thank you. So, so that's why these two things become important. So let's look at this image. So context engineering, if you see, is outside this whole model. We have RAGs. How many of the people in the room know about RAGs? Any raise of hands? A few. So RAGs are obviously retrieval augmented generation used for grounding the data. There is a state or history. There is a memory, which is used like memory, if you see in agent, is like RAM. It's like something which remembers what's happening. Then you have your structured output, because if you are working on agents, most people prefer a structured output. If you're asking a question, they want similar responses every single time. They don't want any deviation. And then you have prompt engineering. So you can see how it looks. It's not a part of this. It's outside the whole thing. It's actually a discipline which helps you to make answers more accurate and relevant. Now, in this whole thing, where this thing fits, this memory. So if you have started in a chat, for example, on ChatGPT or Claude, for a particular time, it remembers what you have asked previously, right? So it's that's called the memory. Now, when you build an agent, specifically for your organization, for your personal use, you need memory, which is actually of 3-4 types, but on high level 2 types. The first is the short-term memory, which is, it keeps track of ongoing conversation, but for a very limited period of time. Simply remembers what you have asked, who you are, what your preference is, depending on what conversation you had. Then the second thing you have is a long-term memory, which is like most people want to use, but hey, it's expensive, every time you call, it's an API call. So this is basically where your knowledge, your preferences, any specific data that you are using comes into play. So if you want to build a really, really cool AI agent, memory has to be there because it's adaptive, personalized, and it can cater to what you need. So I recently worked on a project which was around voice, speech to text. So we were building a voice agent. And the biggest problem was the long-term memory we were trying to build, because people were not satisfied in one go. So after a lot of context shrinking, we were able to build like a long-term memory through which it remembers if the call goes on for like 5 minutes. And bear in mind, there was a translation also involved, where like people talking in different languages can translate it. So several levels of context shrinking was done to make sure it works. But we'll talk about that later in detail. Now, a lot of people think that context is built, we can't change it. But that's not true. So for example, you have some existing memories, which is like the LLM has some existing information available. But then you can also provide new context into it. And these two combined can become your updated memory. It's like you provide more information, like real-time data, so your context keeps on getting updated. So in software, there's a concept of garbage in, garbage out. So if you provide too much information or don't provide that information, the context doesn't remember. So if you are building an agent, for example, if you have to pay council tax, but you also want it to refund your council tax, you also want it to like deal with housing queries, for example, right? Like in public sector, there are a lot of questions like that. You have this existing memory, but you also add like a new context where those two things can combine and become an updated memory. Now, then you create an AI agent which deals with what? Council tax queries, refund of council tax queries, housing queries as well, right? So it's not like context is static. It can be changed based on your real-time data. And LLM actually can be used to create or update these things as well. But that's like a different topic altogether. So context becomes a lot more important as you try to build more complicated applications. Now, there are 3 types of context, actually more, but on high level 3. People think there is only one thing context, there is nothing more. So first is instructions. Instructions, if you read on the right, they're your prompts, any kind of like previous questions or memories you've asked. Second is your knowledge. Knowledge is like your facts, any specific information, descriptions you have. So if you have specific terms, this was asked to me in one talk. Somebody asked me, there are separate lingos or like languages people use in like companies and organization. You have to feed it. You have to tell it exactly what that fact or knowledge is. And then there is a third type, which is tools. So tools is more like feedback. So you must have tried, like when a ChatGPT does not give a right answer, you try to like prompt it a few more times, and that's where the tools come into play. So what the tools does for you is it provides feedback that the answer was wrong, try it again. These three types of main context are used to build the context window, which sits with your LLM. And if you're building AI agent, it's one of the core part of the architecture. So how does the life cycle work? What's the steps involved? So these are the context engineering steps. So the first step is acquisition of data. So before you start building the backend, the context, you need as much data possible relevant to the domain that you are working in. So if you're working for public sector, you need some information around like what specific terms are used, what do they mean, so that the context can pick up. And you fetch it and put it in your memory, train it basically, the model that you have. The second thing is processing that information. So like it's not important what you give, but it's also important what you prioritize, right? So giving data, but then prioritizing which part of the data is important, where you have to provide some sort of indexing so that it understands and identifies the right information. I like to call them topic islands, but people have different terms within their organizations. The third is store. So now you have enough information, you have stored all the things that you need. How will you store it? So you can take either short-term or long-term memory for it. And then for the third and fourth step, you retrieve that information based on what kind of query or memory tooling that you have. And then lastly, you update. So update means every time you are pulling information, you have to feed new information as well. So these 5 steps go again and again if you're building a context in the background, because every single time you have a data, without data it will not work. Let's get that point across. So you need the right relevant data to make sure that the LLM knows what conversation is going on. And when you're engineering that agent, it's important to put the relevant and most latest data into that. Now, very big and very important part is context window. So anybody here has worked on any kind of enterprise level AI agent at the moment? Any show of hands? Okay, cool. So this is important then. Now in real time, what happens? There's so much data, right? It's like an ocean. Okay, imagine an ocean. Now you don't need the entire set of data. You only need a part of that data every single time you run an AI agent. So that's where the context window comes. So what context window does is it picks which part is important, relevant to the query that has been asked. So if you look at the right image, so there is a target token. It identifies a target token to be used. Like, okay, this person has asked me about council tax. Let's talk about council tax. So it will find the target token in that context window, and set the context based on that. Anything towards the left is probably some other information. Anything towards the right may be some other information. It's like infinite. Like it's a bigger pool of data. Okay. And if you see more like in a mathematical form, this is how it looks like. So you will have, for example, these words, for example, in gray are the words where the context is set right now. It's picking up some of the words relevant to the query you've asked. So what it does is making sure that it's incorporating that context every single time you're making the query. When you change the query, it will change the window. So it's dynamic. It makes sure that you're picking the right section. And it's all done when you engineer it, when you build basically. This essentially makes sure that any query being asked or any question being asked is like set to the right tone, the right parameter, and that the hallucination which occurs when you get wrong answers can be reduced to a like much larger level. So look at this query. So I made an AI agent because I have to give a weekly report and I didn't want to do it manually. So I gave this prompt. Now, can anyone tell what's the problem with it?
It depends on context, probably it's it's enough.
I mean, yeah.
Because we had enough discussion, what kind of report.
Yeah.
And what needs to be summarized.
Yeah, exactly. What kind of report this is, I'm not mentioned. What is the duration? I said it's a weekly report, right? Yeah.
I think that the funniest part of your question is that there was daydreaming, and you asked, I'm completely out of the context.
Yeah.
I just read that and I answered what kind of report. So pretty much what the
yeah. So essentially, like when I gave this this query to the agent, it basically just gave me a very, very bad report. So I modified this query several times to exactly tell it what I wanted. And the data was grounded already based on like the internal organizational data so that we can get the right answer. So how does it work? When you make one conversation with an agent, it's called a turn. So every single time you conversate, it's a turn, okay? So this is like my first conversation with like the model that I've created. I am this human person here. And then my tool basically calls a large language model asking generate a weekly report. But what I got, I didn't like it. So I gave like a feedback. I gave another prompt saying, I don't like this report. Can you generate a more detailed prompt? So then that's turn 2. In that turn 2, it incorporates the feedback I gave in turn 1. So every single time when you build an agent to conversate, it's a turn. And it's actually like used largely in a lot of organizations when they build an agent. So if you see in this and in that, there is one initial input and one initial feedback I've given. But when I give the second time, I've given 2 feedbacks, which means like I've given another feedback saying, I do not understand what you have given and given more detailed prompt. So when you build AI agent, this is how you calculate how many turns you had in one conversation. So what we are doing right now, this session is a single conversation, and every time we are conversating, it's a turn. And like when you analyze this data, it tells you a lot about how your agents behave. This is crucially important because feedback loops, a lot of people don't use them actively, and they don't really like invest enough time in building like feedback or giving feedback to LLM that, hey, like this is not what I wanted. Like creating a structured prompt is extremely important along with context so that the LLM exactly understands what is needed here. And this is one example I'm giving. Like one conversation can have 100 of turns, like because people can talk for like 30 minutes, 40 minutes, 45 minutes. There is no limit. Like you can see the data that OpenAI has published, how people use ChatGPT. It's a classic example. So you can see that it's actually way larger than how we imagine at the moment. So let's talk a bit about architecture now. Now that's all concept, but now how the architecture works. 3 main things are needed to build an agent. The first is your large language model. You have to select one large language model that you want to use, which fits your need, obviously the cost of your organizational project buy-in and sort of. You have to decide which LLM you want to pick as a reasoning engine. Then what's the tool or action layer you want to use? Like, are you trying to use some specific tool like Vertex maybe? Maybe you want to use prompt flow. Maybe you want to use Azure. You have to pick which tool or action layer you want to use. And then the third thing is memory state management, because it costs a lot of money. So these things have to be thought before you start building it. You can keep track of like interactions, coordinate everything. And these 3 key components are needed to build an AI agent. Now, this is how it started and this is how it's going. So the first one that you see is like the most basic level 0 agent, where there was a text input, there was a large language model, there was an output. But then that was not enough, not giving good answers. So the second step was created, in which if you see there is a box outside LLM, which means we started giving some context into it, which improved the performance, but not again to a very, very good level. Then in the third step, because we wanted that the answers should be very, very specific, so we used RAG here and grounded a lot more data than before. And we also provided some tool usage feedback that, hey, we're not getting enough information. Then, we thought the text is not enough. We also want to give images, images and videos and maybe like a lot more information. So in the fourth step, you see there are images and videos in both input and output. And we also added memory, because like they require memory, right? Like it will not load without it. So a short-term memory was added into the tool use, next to the tool use basically. Now, once that was done, again, it improved some level of performance, but there was more needed. So then we went to step 5. Now here, the cost was really low, but if you want to build something enterprise level, you cannot go with this, right? Like nobody will use it. So we added vector databases here. Now, I don't know how many of the people in the room know, but vector databases are important because they're significantly faster and they can identify in the semantics which token to pick and runs much faster. So based on the conversation style, we made it more complex. We had a short-term memory for shorter conversation, like 15 minutes, 10 minutes, 30 minutes. But there are people who talk for hours. So we added like a long-term memory. But then we also added episodic memory. We decided which memory type we will add, simply because every person conversates or communicates at a different level. So you have to change the memory type based on which agent, which person is communicating. Now here, because LLMs were not giving sometimes good answers, we had a tool feedback, but we also added a decision box, which means like we wanted like a preemptive layer where validation was happening, that the answer was verified or not. And then again, we had all 3 types of inputs here, same 3 types of output. And now where it is going is this. It's basically the most sophisticated architecture of the AI agent, where you have multiple forms of data, not just text, images, videos. It also has real-time data, some user feedback. Then there is a orchestration layer on the top where you basically connect all the parts together. You will have, for example, things like multi-agent, where like you have created agent for, let's say, one for council tax, one for housing, one for waste kind of queries, multi-agent architecture. Here in the data storage retrieval layer, so this vector databases went here in this section. We also added knowledge graphs here. And then if you see, this was asked to me, by the way, on a talk before, model 1, model 2, 3, and 4. So some people asked me, why do we have separate models here? Why not one? Because they were adamant they want to use one model here. But separate models work better, and they work faster, and they're slightly cheaper as well. So model, if you break down your large language model into smaller large language models, it actually works better in the agents. And then lastly, towards the right, if you see, there's an output layer, which basically includes any kind of customized output you have given or answer. And in the bottom here, there is a service layer, which is mostly about your, if you have multi-channel delivery, like you want to have, you want to use it on laptop, on phone. You also want to use it on like some other website. Like how can you make sure that agent runs everywhere? It's not like running on one single place. So this is how the evolution of the architecture happened step by step. It started from as basic as that, and it's here on this one. So every single step made the performance better. It was not like we went 0 to 1 altogether. It's like a step-by-step discovery of what do you truly need when you're building something which can actually work in production, which can actually be used. Now, I built an agent for evaluation as well. So this is a prompt flow tooling. So if you see here in this one, there is a question, a context, and an answer. So evaluation means I'm checking how the agent has performed, okay? So for example, I gave one value here, some context here, and some answer here, okay? And if you see, like the red boxes just show that this is a description, and that is basically just telling us like you can change or delete or add as many information as you can, okay? Now, once I have given that answer, I've written a prompt. So if you see here, I told the system that you are, for example, an AI assistant, and that you need to evaluate the quality of the answers that I'm getting, right? And the prompt is quite detailed. I've given it a metric called relevance, okay? So relevance, what it does, it checks that the question and the answer, how much similar they are, how much related they are. And I gave them 1 to 5 rating. So 1 means very bad, and 5 means perfect, like great answer. And I want everything to fall from 4 to 5. I don't want anything below that. And then I gave an example. For example, if I give a context question and answer, that if the answer looks like this, it should be 1. If answer looks like this, the answer, like the relevance should be 2. So what it does for me is, it understands exactly if similar questions are appearing repeatedly, it will make sure that it classifies each and every question answer pairing on that level. Now on the right, you can see there's a graph also. So that graph is basically just the nodal structure of this, every single node that you add. And only prompt writing is not enough, you have to write a Python script as well. So this Python script generates the metric, which is like your relevance score. It basically takes a metric called GPT relevance and creates relevance score. So I used LLMs as a judge here, sort of to compare the answers. And in each of these steps, essentially, I'm just matching all the answers that I'm getting to one of the LLMs that I've picked for my evaluation. Once I have done the entire evaluation, it generates this output, which is called tracing the output. So you can click here to see the trace. What it does is it tests everything for like each of the input URLs I have given. It will give me, for example, the system metrics, like how many tokens I have used, what's the duration of that token, what's the GPT similarity. So every time I'm getting 1 or 2, I don't want that. So that's like for failed cases. But if I'm getting 5 or 4, that means it has done well. The answers are suitable for what I have intended to get. It also gives you, like, you can also run batch exports, for example, because in real time, nobody wants to go one by one. So you can run a batch export of like 1,000 or more, basically. And what it does is basically, it will give you like an entire report. You can also download in CSV, which essentially. So this is one of the classic example of how you can like use an AI agent to also evaluate your outputs. Now, tools and frameworks that you can use. So there are a lot of tools and frameworks in the market. I'm not like advocating for one or the other, but largely for most of these, some of these are used. Vertex, for some of the work, for database I've used Pinecone. It's quite expensive, but again, like every organization have their own preferences. You can also use Langsmith along with either of them, or you can also use Azure, like which essentially depends on which company you work for and what their tool stack is. Now, one thing I do want to mention, which most people have missed in the past, is like limitations. Everything comes with some limitations. So the first is like over engineering. I know like we love refining things. Everybody loves, but sometimes we over engineer, and that creates a lot of problem simply because the context is not set right. People miss validation. They don't validate the sources enough. And when that happens, it's a big problem simply because it's not verified. And so nobody trusts it. And trust is really important when you're building a product. Then the next one is your context token limit, which again, like initially when we started building, we thought we have so much tokens, we'll be fine, but no, it didn't work that way. So your API calls, they cost a lot depending on the token size you have. So don't underestimate the token limit. Choose the tool that you want to use based on how much like longer queries you will have, because every single time you're calling, it's calling the API and it's costing a lot of money. And it's real problem, like it's real world problem. It's not theoretical or conceptual. It actually happens when you start building these things. Now, one more thing I want to emphasize is feedback loops, which I said in the start. A lot of people don't use it. I don't know why, but like feedback loops are useful because the large language models, right? They understand when you give them feedback, and it helps to review your output, your spot like errors, and also help in refining. And I think in the previous presentation, somebody also mentioned about human in the loop. So one question somebody asked me is like, who is accountable when you build these things? Who is looking at these things, right? How do we make sure they're right? Which is actually a fair ask, it's not wrong. So you should have somebody in the loop to balance accountability, who is actually also doing some human evaluation at the end of the day, because they can give feedback, corrections, approvals in the initial phases of your testing, so that it's not something you're left entirely on the system. You're actually also making sure that somebody is looking at it constantly. And then lastly is basically, you can also create agent measured outcomes, which means like you set a goal. For example, the goal is to make sure that it evaluates 1,000 responses and it finishes that goal. And then you make sure that those goals are being met. So feedback loops actually work, and because agents, they are not like, they do understand if you provide some feedback depending on how you have created your prompt, and then they learn and adapt at the same time. So pitfalls to avoid. First is prioritize context wisely. If you are using 3-4 things, do not use 1,000 different things. Use only set of data that you truly need. Like if you are only making an agent that is solving 3 problems, only give data for those 3 problems. Don't give data for other 10 problems, because it doesn't work. It gets confused. Second is costing. When you build context, it's gonna be large. You have to optimize it by shrinking it, which means like you have to optimize a workflow that runs for it. And then third is very big and very important, governance. Please do not put PII data loosely on the AI agents, because nobody will use it. And that is true. So it's important to make sure that governance gaps are addressed. If you are planning to use it, like you're trying to make something which is B2B or B2C essentially. If you're planning to use within the organization, might be fine depending on like how easy it is, but for certain industries, it will not work at all. Then this is another use case that was built using LangGraph. So this was an email agent where like there was an email input, an agent was built using LangGraph, and then like essentially an email response was drafted. So here again, like we use like a human feedback. For example, monitoring the agent inbox, like seeing what a response it was using, and tested using Langsmith. All right. So email agent was used with user feedback and long memory. Both of them had context really well done in the backend. we gave like a bunch of old emails for the context for it to understand what topic we are talking about so that it identifies correctly. So this is very easy actually to build if you have like right data. It's not really difficult. What's difficult is again like if you're building something which is more B2B. Now, some final things to cover like before we wrap up. Firstly is like data privacy. Protecting user data, especially in healthcare, financial industries and legal is really important and essential. It's not non-negotiable. Second is bias and fairness is actually a part of large language model, quite large. And AI algorithms, they need to be fair and unbiased. So when you ground the data, you make sure that the data that you are using is not tailored towards one or the other thing. The third is transparency and explainability. So when business is involved, which means people from management are involved, they want to understand how AI has taken decisions. Should not be a black box. So on those cases, it's important to make sure the users understand that. And then lastly, the fourth is security and safety. So again, do not put PII data in your AI agents or any AI application you build because it can be like, it can lose and it can be used very easily. Okay, I have a couple of minutes left, so I'll wrap up. So lastly, don't write this, just fix it because it's context or chaos, it's chaos. The four things I want you to take away from this session is, first is like context engineering makes and works better, reduces hallucination drastically. When we initially built it, it was performing at 50%. With context engineering, it improved up to 80%. And with more engineering, we are planning to make it around 90. So it works, but you have to use the right data and shrink the data as much as possible. Then third is agent architecture, LLMs, plus the tools that you pick, Vertex, Azure, whichever you want to use, along with the memory type. These three things will be there, irrespective of what you build. Then the third thing is prompt engineering is not gone. It's a part of the system. But let's be honest, it's not everything. And then lastly is, it depends on how robust your agent is, that essentially it will be used by like people for like whichever level you are using, internally, externally, and so on. And with that, my talk comes to an end. If you want to connect with me or ask any questions, you can reach out to me. If you have any feedback, you can give it to me. Thank you.